Let's learn how to factor binomial expressions using the difference and sum of cubes formulas. As always, remember to download the corresponding PDF using the link in the description so you may follow along as I work through the problems. There's a few things we should discuss regarding these formulas. First, notice we have formulas for both difference of cubes and sum of cubes, as opposed to the difference of squares formula from my last video. Both a difference of cubes and a sum of cubes can be factored. Second, when using either formula with regular cubic terms, x cubed, y cubed, etc., the second factor here cannot be factored further. Third, you'll often be asked to memorize these formulas in your class. So here's a little trick. Remember it this way. The first sign is the same, second sign is opposite, third sign is always positive. Meaning, for the difference of cubes, this sign will be the same, this sign will be opposite, and then this sign will be positive. For the sum of cubes, this sign will be the same, this sign will be opposite, this sign will be positive. I also included some properties of exponents that we're going to make use of in the upcoming examples. Let's try the first example. Just like a difference of squares, our goal will be to write this as something cubed minus something cubed. And it's just a matter of figuring out what a and b are for our specific problems. Something cubed minus something else cubed. The first part is just x cubed. 27 is 3 cubed. Since we're using the difference of cubes, the first part is going to be x minus 3, same sign. Next number will be squared, so x squared. Now opposite sign, plus the product of our a and b, so 3x. And the last term always has a positive in front, plus 3 squared is 9. That's as far as we can take that. Next example is a sum of cubes. We will write that as z cubed plus 8 can be written as 2 cubed. Then we'll apply the formula. Z plus 2 is the sum of cubes. Next term will be squared, z squared. Opposite sign, so minus the product of 2 and z, so 2z. And then finally plus b squared, 4. Next example, don't get mixed up if the number and the variable are swapped. Still a difference of cubes. This is 4 cubed minus x cubed. Difference of cubes. We'll have 4 minus x. And we'll have a squared, 16, plus the product of 4 and x, 4x. And then finally plus x squared. Now we have some more complicated coefficients. That's okay, we can still handle it. We'll write this as something cubed minus something cubed. So we know we're going to have a y and a theta in our parentheses. But what cubed gives us 8? We already saw that earlier, that's 2. What cubed gives us 125? 5. These are our a and b expressions. Now we write the formula out. 2y minus 5 theta. Then we'll have 2y squared plus the product of 2y and 5 theta. And then finally, 5 theta squared. Notice I didn't simplify in this step. I don't want to do too much at once. I can simplify in the next step. That way it's easier to go back and check my work if I make a mistake. 2y minus 5 theta. Now we'll apply our first property of exponents. This exponent will get applied to each factor. We'll have 4y squared. Here we'll just multiply. 10y theta plus 25 theta squared. Now we have an example where the coefficients are not perfect cubes, but we can handle it the same way. Something cubed minus something cubed. We'll put in our variables y and z. Now there's not a nice number that cubes to give you 7, so we just write it as the cube root of 7. Same thing with 11, cube root of 11. Then apply the formula. Cube root of 7, y minus cube root of 11, z. Being very careful to keep our radical signs off of the variables. Times cube root of 7, y squared minus the product of the cube root of 7, y, and the cube root of 11, z, plus the cube root of 11, z squared. Cube root of 7, y, minus cube root of 11, z. Now, how do we square the cube root of 7? There's a couple ways to do it. Using the third property of exponents, we can write the cube root of 7 squared as the cube root of 7 squared, which is the cube root of 49. We're just applying the exponent inside the radical. So this will be the cube root of 49 y squared minus the second property of radicals says that we can multiply the insides of our two radicals here and have the cube root of 77 yz plus, just like before, this will be the cube root of 11 squared, 121 z squared. Our last example here is a little more tricky, but we'll try to write it as something cubed minus something else cubed. The number that gives us x to the 6th when we cube it would be x squared. And the number that gives us 64 when we cube it is 4. Over here we have y squared will give us y to the 6th, and 3 cubed gives us 27. We'll apply the formula. 4x squared minus 3y squared, 4x squared squared plus the product of 4x squared and 3y squared plus 3y squared squared. We'll start simplifying. Be 16 x to the power 4 plus 12 x squared y squared plus 9 y to the power 4. On this example, we're not done. This expression here is a difference of squares, so we can take that a little bit further. Something squared minus something squared. 2x squared minus square root of 3y squared. We have a little mini difference of squares problem in our larger difference of cubes problem. Remember the difference of squares formula, a minus b times a plus b. We'll have 2x minus square root of 3y times 2x plus square root of 3y. That's just the difference of squares there. And then we will carry this piece down. 16x to the fourth plus 12x squared y squared plus 9y to the fourth. And that's as far as we can take that problem. So if you found this video helpful, make sure to like and subscribe for more math tutorials. And if you have any questions, drop them in the comments or join us on Discord. Links are in the description. See you next time. God bless.